Hello everyone, I'm here today with another Leetcode practice video. For this video, I've picked out a random problem that I have not solved before, and I will just film my thought process as I go through the problem. So let's take a look at the problem. Top k frequent elements. Given an integer array nums and an integer k, I want to return the k most frequent elements within the array. The test cases are generated such that the answer is always unique, and I may return the output in any order. So for an example where we have 1, 2, 2, 3, 3, 3, and k of 2, I want to return 2 and 3 since they are the top two most frequent elements in the array. I imagine if k was 3, I would return 1, 2, and 3, and if k was 1 in this situation, I would just return 3. So let's just take some quick notes about this problem. First things first, what is the input and what is the output? So the integer, well, the input, there are two inputs that we're getting here. First is an array called nums and an integer called k. And the output is another integer array that just represents the top k most frequent elements. Some context conditions that I want to keep track of is that the answer is always unique, and I can return the output in any order. So this means that something like 1 and 2 is the same as 2, 1, for example. Okay, let's take a look at the constraints. Num's length will be between 1 and then 10,000. So we won't have a certain edge case where nums is empty, and we'll have to figure out what to return there. So between 1 and 10,000. Each number is a range between negative 1,000 and 1,000. Not much to be told there. And then a note about k. K will be between 1 and then the number of distinct elements in nums. So we can't have an edge case where k is greater than the amount of elements in nums, and then we can't return anything, or we can only return up to a certain number. So I would definitely mark this as an important constraint. So for any edge cases, the way that this problem is set up, I don't think that there are too many edge cases to consider. We don't have a case where the code breaks and we'd have to choose one or two options that haven't been explicitly stated. In the case where we just have a numbers array with one element in it, we can probably just return that same array. But this also goes for the second example here, where if the numbers array only has the same element in it, then we can just return that same element either way. So I'll just not consider edge cases for now. And let's start working up a plan. Some other things that I want to note is that I am coding in Python, and I know that Python, to be honest, I'm used to solving without imports, but I know that Python has some like import like from collections, or import count from collections, I believe. Or perhaps I'm getting the name wrong, but Python has some library that, say, if you wanted to import, would provide that provides the count of each element in the array, so you could very easily figure out how often each element appears in the array. If I use that for my solution, I would just have to use that library, very quickly pull out which elements are the most frequent, and then just return that array. But for this example, I will solve this. I will solve this with a dictionary. So let's discuss a couple other algorithms first. Say one. Let's say like a brute force or naive approach, and let's just say that for this first approach, we'll use a variable to count the frequency of each element, as in we go through the nums array once for each element, and then count the frequency of each element, and then compare them at the end. But how would that look? Well, let's say we had to choose just one element at a time using this variable approach, and not really touching the dictionary here. And we just wanted to see which number was most frequent, k number of times. So let's say for this first example, we want to loop through nums k times. We want to use the variable to count the frequency of each element. Or perhaps not k times, but once for each distant element. We want to use a variable to count the frequency of each element, and then we'd add the element to an array that we'd sort based on how common it was. I'm sure it would take a while to figure out sorting with this approach, and all things considered, it would be pretty slow. It would be O of n, where n is the number of is the length of nums, and then times, let's say d, for the number of distinct elements. And something like that would be too slow for what we're looking for. Ideally, we could get through this this whole problem with just one iteration. Space, it would take about the same amount of space if we just use a dictionary. Probably just O of n. No, O of d. Probably one, like, linear space depending on the amount of distinct elements. So let's take a look at the dictionary approach. We loop through nums once. For each element, we add it to the dictionary. Dictionary or map or hash or some way that can store a value and a key. Key is the element, and the value is the frequency. And of course, well, with Python, if if we attempt to add an element to the dictionary and it doesn't already exist, it will automatically create an instance. Whereas for certain other languages, we may have to, the code to add something into the dictionary will be different from creating the key value pair in the dictionary. So let's go back to our approach. We loop through nums once. For each element, we add it to the dictionary. And then once we have our dictionary, how do we convert that to the output array? So what we can do here, we can use a sort array, but this may take potentially all of log n log n time, or the length of the dictionary in terms of time. And we really just need the k most frequent elements. So we would just need to, once again, we just loop through the dictionary. K times. We only need to look through the specific elements that, this k number of elements. Take the maximum value, or the most frequently occurring element, and append that key into our result array. And then once we're done with this secondary loop, we should have an output that looks similar to the ones in the examples. And finally, for the time and space complexity, we will have O of n, where n is the length of the nums array, and the space will be, let's say, O of d, just linear to the number of distinct elements. Okay. Let me get started with the coding now. variable to keep track of the frequency, and then another one to just keep track of the element itself. That's not where I want to. Okay, so I believe from my code, what just happens is all of the numbers get added to the frequency table. Then we loop through the frequency table in order to pick out the k most frequently appearing elements. So this loop will occur once for k times, and the inner loop will just iterate through the frequency table once and pick out the most frequent element and another variable to keep track of the frequency itself. At the end of that loop, we'll figure out what the current most frequent element is that's in the dictionary. We will append it to the output, and then we will delete it from the frequency table so that we do not catch it a second time in the next iteration of the dictionary. Once that's all done, we will return the output. So let me try running this and we'll see what happens. Okay. Oh, I meant to write num there. Okay, there is some type of key error here. I believe that the way I wrote this is incorrect. I think I do need to check if num is in the dictionary first. Okay, let's try that again. Key error 1. Oh, okay. So now I need to make sure that this is iterating correctly. Okay. Yeah, this isn't the correct way to iterate through a table. Okay. Let's do a quick review. Would I iterate through the frequency table by looking at a pair? Maybe it's looping by the key when I attempt to do this. Okay, let me try this again. So let's say for num in the frequency table, I want to get the value, so I want to get the frequency table. I think I'll call it key, just because I think that's easier to understand. So for the key in the frequency table, if the value is greater than the current most frequent element, then I replace replace my current variables. Now let's give this another try. Okay, just as a sanity check, let's print out the frequency table with each iteration of this loop. Ah, okay, no, I did do this wrong. Each time I delete an element, essentially the goal here is that I want to reset the reset my variables, but I didn't exactly do that here. So I think I will initialize these two variables inside this for loop here. This seems to be a better place to put them. So let's try that again. And now it is behaving as expected. I have an option to visualize my code. Oh, no, this is just asking an AI to do that for me. Okay, with that said, I think I can submit this and we'll see how it handles the test cases. And that is another problem solved. So in terms of runtime, it seems like I have the optimal solution. In memory, I think I could maybe use an improvement, but then again, it is a bit hard to tell with Leetcode whether or not your runtime or memory beats their solutions. Let's take a quick look at the solutions before I end this video. Sorting, that's not the one I did, but it is a very valid approach. Yep, it does involve building a list and then sorting through it in order to get the result. That is also n log n. The next one is a min heap. A min heap is perfect for this because it always keeps the smallest element at the top. By pushing frequency value pairs into the heap and removing the smallest whenever the heap grows beyond size k, we ensure that the heap always contains the top k most frequent elements. In the end, the heap holds exactly the k values with the highest frequencies. I see. Now let's take a look at the third solution. Bucket sort. Each number in the array appears a certain number of times, and the maximum possible frequency is the length of the array. We can use this idea by creating a list where the index represents a frequency, and at each index we store all numbers that appear exactly that many times. So all numbers that appear once go to the first group, all numbers that appear twice go to the second group, and so on. And then once we build these groups, we look from the highest possible frequency down to the lowest, and we collect numbers from these groups until we have k of them. One question I have about this approach is that it seems to make groupings of the elements by frequency, and I think that this specific question has a constraint that prevents this scenario. Or perhaps I'm not understanding this solution. I see. So this would work just as well, from what I can see. It gives you a very easy way to sort through, just sort through the whole array at once. And this is O of n time and space. Okay, I think creating another element for D probably was, I think it would just be considered n as well. But and I think in terms of time, since I am looping through the list, the dictionary again, it could probably look something along the lines of n plus k or times k. It's a second loop, so it may be n plus k. Okay, so I think I got some good information from these solutions, and I submitted one of my own. But yeah, I think that settles it for this problem. I think I would definitely like to revisit it in the future and then have a go at implementing one of the other solutions. But for now, I think that's it. Thank you very much.